my final project presentation. My name is Kevin Lee. I'm a third-year undergraduate student majoring in computer science and information science. Today I want to discuss a little about my seam carving project. In image resizing, simple methods such as scaling and cropping have clear drawbacks. If we take a close look at the image, scaling causes obvious distortion if the aspect ratio is different between the input and the output. As for cropping, it will discard too much information of interest if the output resolution is significantly lower than the input resolution. What Whedon and Shamir show in their paper is a technique known as seam carving. This technique first identifies low energy areas of the image that are less interesting, then finds the lowest energy seams that weave through the image. The magic here is in finding the lowest energy seam. To do so, we first assign each pixel of the image an energy. To compute the energy of a single pixel, we look at the pixels to the left and right of that pixel. I found the squared component-wise distance between them, then add them up. We do the same for the pixels above and below the center pixel. Finally, we add up the horizontal and vertical distances and take the square root of it. To find the lowest energy seams of this image, we choose to apply dynamic programming. One thing to notice is that the greedy approach doesn't work here. I tried greedy by picking a low energy pixel early on, but I got stuck in the higher energy region of the image. Unlike the greedy approach, our DP algorithm essentially tries all possible paths through this image. It's just that when trying all possible paths, the same subproblems are solved again and again, making this approach a perfect candidate for dynamic programming. I defined the function mxy that represents the energy of the lowest energy vertical seam that starts at the top of the image and ends at the pixel at the bottom. So here is the result of the carved plateau picture. The image below the original image is the following lowest energy seam, and we got some desirable effects in the results image on the right side. And here's the picture taken by myself. We can notice that as we shrink more of the picture, it removes more parts of the sky and remains a larger portion of the building and the beach. We also got some interesting results by choosing different kinds of pictures. In the given textbook example, although the left and right pictures look the same, it's actually a bit different because the algorithm chooses to cut the left page first, which results in the asymmetry in the center picture. But as we shrink the image more and more, the areas of left and right pages will eventually get closer, which you can see in the result at the right side. So there are numerous possible extensions to this work. We would like to extend our approach to other domains, the first of which will be resizing of video. And we would like to investigate the possibility of combining two approaches, specifically to define more robust multi-size images. We would also like to find a better way to combine horizontal and vertical seams in multi-size image. That's it. Thanks so much for listening.